Hey guys, let's discuss new topic today from system design, which is called AI powered search system. So we will be creating here, we will be designing here AI powered search engine where we will be using Elasticsearch as a traditional way, okay, and then we will see the AI ways also, like we will be using vector and all, okay. So here the introduction will be. Okay, a search system enables user to retrieve relevant information from large data set, okay, using keywords, filter, natural language queries, okay. Modern system combines traditional search and AI powered search. So in traditional search, it would be keyword based search. So for example, I have typed shoes, so it will give me all the result related to shoes. Okay, so this one definitely will be fast and deterministic. Okay, and then second, AI powered search, so it would be semantic and vector based. Okay, semantic in the sense, if I say I want shoes under 2,000 rupees and only Nike, so he should understand the context and then should give me the result according to that. So it is intelligent and contextual. Okay, so for example, e-commerce, you can give red shoes under 2000, or for YouTube you can give system design tutorial. Okay, and for AI search you can say video to learn distributed system quickly. So he should be able to answer give you that result. Now functional requirement. So functional requirement, if we talk about here, for functional requirement we will be talking about two things: core feature and AI feature. Okay, so we will be talking about core feature and AI feature. So in core feature, user should be able to search full text search. Okay, so like whatever I have written, it should be able to search that. Now filtering, so filtering according to price, category or date. Okay, and then sorting, so relevance and popularity basis. So what is relevance here? Like how well a search result matches the user's intent for a given query. So whatever is my intent, it should return me the result for that only. And then autocomplete, suggestions, pagination, ranking, these all things should be there. Now AI feature, if you talk about, so semantic search means understand intent. Okay, if I am saying that I want a Nike shoes under 2000 rupees, then he should understand that I don't want cheaper one, I want the best one, right? So query rewriting, okay, it will help you there. Personalized result and conversational search, chat based, like we do for chat GPT, right? So that thing. Now API design, if you see if user is searching something, okay, so let's say this is the get request and slash API, okay, is your mapping. Now here query will be running, you required running shoes, okay, and he knows that price is less than 2000 is the filter here, and you're sorting it according to popularity and page number. Okay, so this is something like this, you will get the response. Okay, now here this one is 1200 result you will get. Now non-functional requirement, if we talk about here, so low latency, okay, P95 less than 100 millisecond means all the request 95% of the request should you should get response in 100 millisecond, less than 100 millisecond time. Okay, then high availability 99.99%, your system should be available. Scalability, billions of documents, so here we are talking about billions of document, we will be searching from billions of document only. Okay, now fault tolerance and near real-time indexing. What is near real-time indexing? And so near real-time indexing, NRT indexing, is data becomes searchable almost immediately after it is added, but not instantly. So I just added the data and it should be immediately available for the searching. Okay, but it is not like I've added and I will be able to search like after 1 second, let's say. Okay, typically within 1 second or a few seconds it should be available. Now the next is why near and not real time. So here we have talked about real time indexing, okay, and not the here we have talked about near real time indexing, okay, and not the real time indexing, because see in systems like Elasticsearch, when you insert a document, okay, it is not immediately inserted and searchable. Okay, there would be some process which he has to follow. So for example, it first goes to memory buffer. Okay, in RAM memory it will go there. It is not searchable right now. Then we will create a segment with it. Okay, and after that, when you run refresh operation, after that only it will be able to search, means user will be able to search it. So only after a refresh does it become searchable. Memory buffer. So here if you talk about what is memory buffer, so when you insert a document, it goes into RAM memory. Okay, first fast but not searchable yet, because it is RAM in memory, so it would be fast. Okay, but currently it is not searchable, your document is not searchable. Then segment creation. Elasticsearch converts buffered data into a segment. Okay, and then a segment is like mini searchable index or immutable. So immutable means we cannot change it. Okay, now refresh operation, this step makes the segment visible for search. So after that only, now high level architecture, if you see here. Okay, so here user will send the request. Okay, he will search something, so that will go to API gateway. API gateway will handle your routing thing, authentication, rate limiting thing. Okay, and then after that it will go to search query, search service. Now here you can see two things. One is AI service and second is Elasticsearch cluster. Okay, so Elasticsearch, you can say, is a database where we search our document or query. Okay, so here user will search a query and he will get the result. Then you will ask me that if you're searching here, okay, where you can see shards and replicas. Okay, so shard you're using for the scaling, and replica you're using for the availability. Okay, and then you will have a node, different nodes, and you can search the result from there. Then why we are using AI search here and then this vector store and all those things? So see, this is the traditional based searching. Okay, Elasticsearch. And now here if you wanted to use AI feature, then we can search using vector as well. Okay, so AI service which is optional right now. Okay, optional, and we can have this system as hybrid as well, or it will give you result from both the ways, right? So it would be very nice, very good result. So AI service, what it will do, it will understand the query. Okay, it will understand the query and it will do embedding, okay, of your query. It will convert into the numbers, then re-ranking the recommendation, whatever it is getting from VectorDB. Okay, so now here if I talk about in short, so you can say user send a search request, it goes through API gateway to the search service which processes the query. Okay, the search service query Elasticsearch cluster. So this is your cluster, Elasticsearch cluster, where you have multiple nodes, similar kind of nodes. Okay, the search service queries Elasticsearch cluster where data is stored in shards for scale and replicas for reliability. Okay, optionally AI service enhance the query using embeddings or re-ranking for better result. Okay, so here you will get the better result, because we have seen that in traditional based it is a exact word search. Okay, and here if you do with AI search, okay, so that will take the context. It would be contextual, it would be intelligent. Okay, so if vector search is used, it queried the VectorDB to find semantically similar result. Example, searching best budget phone. Okay, so Elasticsearch finds keyword matches, AI improves relevancy, and final ranked result are returned. So both you can use hybrid mode. So two types of search happening here. Okay, the first one is keyword based search, and second is semantic search. Okay, so keyword based search is your traditional one, which is Elasticsearch, and semantic based search is your AI based, which is VectorDB. Okay, so here works like Google search, matches exact word in traditional one. So like query is budget phone, so it finds document containing budget and phone. Okay, so all the document which is containing budget word and then phone word, it will take data from that document, whether it is relevant or not, it will just fetch the data. So it would be fast but doesn't understand meaning deeply. Okay, but here in semantic search, understand meaning, not just word. Okay, uses embeddings. Here we use the embeddings. Example, like for example, query is cheap smartphone. Okay, so it can match budget mobile and affordable phone and not the cheap one. Okay, so this is smart, and but it is slightly heavier because we will be using here different kinds of algorithms. Okay, and you use vector here. Okay, VectorDB. So we will see how we are storing data in VectorDB. Okay, and why it is multi-directional values we take there. So we'll see all those things here, but now Before that, see the actual flow. Okay, so actual flow, user send query best budget phone. Okay, so goes to search service. So now here two paths can happen, two paths, one for AI, second one is for Elasticsearch. Okay, so option A on the Elasticsearch means basic system. So search service will go to Elasticsearch and it will return you the result. So used when simple search and fast response is needed, you will go with that. Okay, then after that, hybrid. So hybrid, first so your Elasticsearch will find the result, okay, keyword search, and second user search service will go to vector DB, and semantic search via AI will happen there, and then result from both are combined and re-ranked. Okay, so you will get the better result here. Now right path. So let's say you wanted to write something, you have API, okay, and you're searching something. Let's say in your application you're searching Nike running shoes, okay, or let's say I have added my product, okay, Nike shoes, and I have added the description Nike running shoes. Okay, so I'm sending this to API. Now API will send this data to Kafka. So for API will be the producer, okay, currently here. So a new product, Nike running shoes, is added. Okay, so through Kafka we will be adding it to the Elasticsearch, because that is kind of a DB for us. It goes to Apache Kafka, indexing service processes and store it in Elasticsearch. Okay, this ensures high throughput and decoupling, because we are using here messaging queue asynchronously, that's why. Now read path. So how read path will work? Search flow, if user is searching something, so that will go to API gateway, then from there search service, then Elasticsearch, and then result. Okay, so the two ways, like write path and read path, we have just talked about. So user search running shoes, okay, and then search service queries Elasticsearch, return ranked results. So this ensures low latency. Now traditional search system, okay, if you talk about Elasticsearch based searching, so if we talk about that in detail, so first one is your data flow. Okay, so traditional search data flow, data ingestion and plus pre-processing. See, when you the raw document is something like this: the best running shoe for man. Okay, let's say I have my application like Amazon. I have added the product and I've given its description, the best running shoes for man. So API will give this data to Kafka, okay, and then Kafka will store in Elasticsearch. But before storing, so first what they do, they remove the stop words. Okay, so stop words means like the, for, is, these things they will remove. Then after that, so it will become best running shoes man. Okay, then now they will do normalization. It means that they will convert it into the lowercase. Okay, then after that they will do the stemming on it. So stemming means they will remove this like for example runner, okay, or the shoes. Okay, it will convert it into the shoe, run, and this kind of things. So they will do stemming on it, so it will become run, shoe, man. Okay, now second one is inverted index creation. So it means that they will not directly go and then will create one document and insert this value into that document. No. Okay, what they will do, instead of storing full document, Elasticsearch creates a map. Okay, map like best is stored in document 1, running is stored in document 1, okay, shoes is stored in document 1 and 5, and then man is stored in 1 and 3. So he will create a map there. You will store these things in a database, but mapping you will use here. Okay, and then this allows fast lookup instead of scanning all the document. Okay, let's say you have created all, you have written these all things, this thing in a document, then you have to search all the documents that where is this value. But if you store this in a particular document, then you just when you will fetch the things, for example for this run, shoe, man, so only the document which has these words we will get that in result. Okay, so now query processing. So let's say user is searching running shoes. Okay, so when you process it, it will process something like this, running and shoes, two different words. Okay, after that search plus ranking. So system looks for let's say he found running word in document 1 and shoes in document 1 and 5. Okay, so common document between these two is document 1, document 1. It means that it has the higher relevance. Okay, and document 5 appears on the in shoes, so lower relevance for that. So it will give the ranking. So for example document 1, okay, it will give the one ranking, and second it will give document 5 for this. Okay, so best running shoes for men, this is more relevant than casual shoes. Okay, so 1 will be your answer, it will return that 1. So that is how this thing happens in the memory. Okay, so the first one is data ingestion and pre-processing. We do some pre-processing on data, like remove the stop words and then convert that into the lowercase, and then stemming, and then we store that in terms of inverted index. After that we process the query, and then we give the search and ranking. Now 5.2 is core concept. Okay, so core concept is same, but here see, we are talking about index. Okay, so in Elasticsearch we create index. So index is nothing but like a logical namespace, like a database. Okay, so for example, products underscore index. Now here this is the document. Okay, document looks something like this. So you're storing values here. Okay, you don't have row, column or rows and in table format. Okay, it's a JSON object you have here. So you stored a JSON object in that index, something like this. Okay, after that we use here sharding. Sharding means horizontal partitioning of the index. Okay, so we will store in different servers. Enable parallel search. Okay, so in different search you can search at the same time. So parallelly you can search, it will save your time. And then replicas, so copies of shard and use for fault tolerance. Now inverted index we have already talked about. Okay, it will take order 1 search complexity. And then query execution. So like example query, for example, the query is red running shoes. Okay, this is the query. So first it will tokenize it, so it will convert it into red running shoes. Okay, 3 different words. Now after that, match documents. Okay, so it will match that from the documents, and we give the score to that fetched result using TF, IDF and BM25 algorithms. Okay, we will see what is that, and return ranked result. So this is the simple flow. Okay, now here TF IDF is your term frequency and inverse document frequency, TF IDF. Okay, and then is a basic scoring method, so we just give the scoring using this method. Okay, while BM25 means best matching 25 is an advanced ranking function used in Elasticsearch for more accurate relevance. Now these are the ranking algorithms. Okay, so here ranking algorithm BM25, so used by Elasticsearch to decide which result should come first, because it is giving the ranking, right? Now key factor, if you talk about here, so 3 key factors. Okay, the first one is your term frequency, and then document length, and then third one is inverse document frequency, IDF. Okay, so term frequency is how many times does the word appear. So more accurate, more occurrences means more relevant, right? But only till some limit. So for example, if in document 1 you're searching for Nike shoes. Okay, so in document 1 you found Nike shoes, so this is the good one. But in document 2 if you find Nike shoes, so that is not much better. Okay, so here BM25 avoids over rewarding repetition. So here it is over rewarding repetition, right? So BM25, and it will give the score to the documents, it will take care of these things. Now document length, is the document too long, it will check. Okay, so long document naturally contains more words, so BM25 normalizes this. Okay, so document A, short and focused, best Nike shoes, and document B is very long blog with many random words. So short focused content gets a fair advantage here. Inverse document frequency, IDF, so is this word rare or common, it will check that. Okay, rare words, so more importance will have. Okay, and then common words, so less important. Now final intuition, so BM25 is basically asking does this document contain the word, not spam it, stay focused and use meaningful words. So all these things it will check. Now additional ranking signals we also use. So on the basis of CTR, okay, click through rate, how many times user has clicked it, and then conversion rate, okay, after clicking it, how many users have read it properly. Okay, then ratings and review, freshness, new products, and then user personalization. So we take these signals also consideration. Now example, running shoes. Okay, query is running shoes. someone is typing running shoes, so he wants the result from running shoes. Okay, so product A, high clicks and high rating it has, and product B has low engagement, so product A rank higher. Okay, that is the understood. Now it is used by companies like Amazon and Google. Okay, feature. So now for feature, we will use first is filtering. So we will filter according to the feature. For example, price is less than 2000 and category is footwear. Okay, and we sort it on the basis of price, popularity, rating. Okay, and autocomplete. So here if user is searching something, okay, and we need to give autocomplete suggestions him, so we use two ways here. One is age n-gram and second is prefix matching. Okay, so age n-gram is nothing but n-gram means see, breaking a word into prefixes. For example, if it is a shoes, okay, so shoes will get generated in age n-grams, like s, sh, sho, shoe, shoes, okay, something like this. So when user type sh, so it will match with shoes. Okay, if he is writing sho, again it will match with shoes. Okay, so because you have already created its n-grams, okay, so it will search from that. Now helps autocomplete as user types. Prefix matches, second one is prefix matches. So prefix matches directly checking if a word starts with a typed prefix or not. Okay, so for example, stored word is shoe, shoes. Okay, and user has typed sho, so system will check whether shoes starts with sho, then it will just return true. Now difference between both is that, see, the first one, age and grams done at indexing time, means faster search later. Okay, indexing time only it happens, and then prefix match done at the query time. So it is simpler but slower at the scale. Now scaling strategy. So here if you wanted to scale your application, you will use sharding for horizontal scaling, and then replication for availability and caching for Redis. Okay, after that, if you talk about here fault tolerance and failure handling, how you will do this. So if shard fail, then if one shard fails, replica servers data. Okay, so another server data we will replicate it. Now because we have the copies of servers, right? Then node failure, so cluster redistribute shards automatically. If that node is failing, then we will use the another node, okay, from the cluster. And Kafka failure, so message written reprocessed later. Okay, so in Kafka we have a feature that we can reprocess later, okay, if it is failing. Now example, one Elasticsearch node is crashed. Okay, so replica node takes over, and no downtime for users, means replica node will work. Okay, so there will be no downtime for the user. Limitation of traditional search. So exact keyword dependency. Okay, if it is exact, then only it will return you the result. Cannot understand intent, and poor result for best shoes for marathon or videos to learn system design. He will not be able to understand what is the intent there. AI powered search system, if you talk about, so core idea is instead of matching word, we will use the semantics. Okay, now keyword key components is embedding model, vector database. Okay, and architecture, we will see the architecture of it, and after that we will see one example, and what is similarity search. Okay, so here let's talk about embedding model. So what is embedding model? See, we convert text into numbers. Okay, text into vectors, you can say. For example, if the query is running shoes, it will get converted into something like this, numbers. Okay, vector database, so stores embeddings. So these kind of embeddings we store in a vector database. So for example, Pinecone, FAISS and Elasticsearch vector support. Okay, we use these databases. Now architecture, if you see here, this is very simple. See, user is running query. Okay, then embedding model will generate its embeddings, and then vector search will happen. Okay, so this vector DBs, FAI, SS Pinecone. Okay, these are the DB. So find similar vectors in the vector database. Okay, so we are finding the result. We need to find the result. So it will search into that database, and then it will find top k result, then we will rank them, okay, using the model, re-ranking model, and then final result user will get it. So this is very simple. Okay, so if I talk about in a text format, so user query is first converted into vector using embedding model. Okay, then vector search ANN finds a similar document based on semantic similarity, and top k relevant results are retrieved and passed to re-ranking model for better accuracy. Finally, the system returns the most relevant and well ranked result to the user. Now example, so like comfortable shoes for long runs. Okay, let's say you have this. So traditional search might miss the result because he will not able to find this exact search, but AI will match marathon running shoes and long distance trainer. Okay, now similarity search, if you see, so we have two things here, cosine similarity and dot products. Okay, okay, so see, similarity search is we use using the cosine similarity and dot products. Okay, so when text is converted into vectors, the system needs a way to check how close are two meanings. So we have converted the text into the system, okay, vectors, and now we need to check with the documents, okay, with the other data. So we will check with similarity, how much similar it is. So for example, if you have a query running shoes, okay, now stored items are marathon shoes and formal shoes. So who is more closer? This one, marathon shoes is more closer than this running shoes, right? That formal shoes, we don't run by wearing formal shoe. So each is converted into vectors or a numbers, you can say. Okay, now here cosine similarity. So cosine similarity measures angle between vectors, range -1 to +1. So how, see, closer to 1 means more similar. Okay, so for example, if the running shoes and marathon shoes, okay, the angle between them is 0.95, and then running shoes and formal shoes is 0.40. So who is closer than one? This one, right? So this is the similar one. Now that one will be the answer. Now dot product. So what dot products? We measure overall alignment plus magnitude. Okay, so how, see, higher value means more similar here. So now how, see, often used when vectors are already normalized. Okay, so like dot products measure how aligned two vectors are and how strong they are magnitude. Okay, so how strong they are. So for example, if you have a query running shoes and you have converted it's a vector, so your query's vector is 2,3. Okay, this is not exactly we are converting, it is the meaning, you can say. Okay, now document A is marathon shoes and casual shoe is in document B. So if you find it's a vector, so 2,3 and 1,1. Now what you will do, you will find the dot product of it. Okay, here what we are trying to do, we are just trying to find which document is more similar to the query. Okay, so here you will find the dot product. So how, see, query into document 1 and query into document B. So query means 2 into 2 and 3 into 3, and we will add that. So 2 into 2 plus 3 into 3, this is 13 and this one is 5. So what is the higher value? 13. So this one is more closer. Okay, so what is the interpretation here? 13 is higher, very similar, strong match, and 5 is lower, so less similar. So this is so document A ranks higher than document B in the answer, in the result. So difference, cosine similarity compares direction and dot product compares direction plus strength. Now ANN, okay, we were seeing vector ANN search. So what is ANN? See, ANN is approximate nearest neighbor. Okay, so in vector, let's say you have converted your text into embeddings, okay, and stored in a, and you are just finding it from a vector stored database. So in that vector database also we have lots of embeddings, okay, and we cannot go and check that embedding, query embedding with all the stored embeddings. Okay, so we just find the nearest one. Okay, we find the nearest one which is more similar, and we find we just send the result. Okay, when we convert text into vectors, and so we will have hundreds of dimensions. Okay, and by 100 of dimensions we will check here in this lecture only. Finding the exact nearest match by scanning everything is very slow. So ANN is like approximate nearest neighbor, almost nearest, result much faster. Okay, slight approximation, huge speed gain. So for example, if query is running shoes, okay, if query is running shoes, then database has millions of vectors like marathon shoes, sports sneaker, formal shoes. Okay, so without ANN, if we goes and compare all these things, it will be with every vector, so very slow. Okay, with ANN, quickly jump to small relevant region and find that the answer is marathon shoes and sports sneaker. So may skip a perfect match sometimes, but very accurate. Now, what does hundreds of dimension mean? Okay, so see, when we convert a text into vector, okay, like we call it as embeddings. So we represent it as a list of numbers, right? Like this. So each number is one direction. So this is one direction. This is second. This is 3, 4 different directions. Okay. So simple analogy. So like see, if you have only one number there, so this is 1D. Okay, a line. Then if 2D, then a plane XY. Then 3D, so XYZ. Now here we are talking about multi-directional. Okay. So if there is 100 direction, so it will be something like this. 768 direction, it will be something like this. Okay, so that means we mean by hundreds of dimensions. So now, why so many dimensions we are using here? So because language is complex. Okay, this is very important thing. See, each dimension captures some hidden features. Like if we are talking about topics, so there could be a multiple topics, right? It could be sports topics, tech or finance, in different direction that one can go, right? Then if you are talking about sentiment, so that could be positive or negative sentiments. Now if you are talking about context, so running could be exercise, or running could be code as well. Okay, and then relationship between words. So one or two numbers are not enough to capture all the meaning. So what is the intuition here? Think of it like this: each dimension, one signal about meaning. Okay, so more dimension, more detailed understanding, right? So for example, if 1, 1, this is the value, so very basic meaning. But if you have a multiple numbers here and hundreds of values, so it means rich meaning. Okay, we can find more intent around it. So now real world example. So we are using model like BERT and OpenAI embeddings. Okay, so BERT is 768 dimension model, and this OpenAI embeddings is 1536 plus dimensions. Okay, so a sentence becomes sometimes like running shoes, like 1536 numbers. Okay, array of 1536 numbers in this OpenAI embeddings. Now hundreds of dimensions simply mean instead of describing text with 2 to 3 numbers, we use hundreds of numbers to capture deep meaning. Okay, so now algorithm, HNSW and IVF. We will talk about two algorithms here. Okay, hierarchical, navigable, small world. Now you have lots of embeddings. Now how you will find your match? So see, in this hierarchical, navigable, small world, you see the hierarchical is here. Okay, so it will be like, it's like a multi-layer graph. Okay, you have multi-layer graph. So top layer, few nodes, lower layer, more detailed search. Okay, fast navigation. So for example, you will start broad and then quickly narrow down. Okay, and find the nearest neighbor first. IVF, inverted file index. Okay, so here things like clustering. Data is divided into cluster or groups. Okay, search only in the closest cluster and not entire data. So query goes to a sports shoe cluster, search inside it only and not in different cluster. So now hybrid search, if you talk about, so hybrid search, this is the best practice, and here we use hybrid search, combine keyword search and semantic search. Okay, both vector search and your Elasticsearch. So let's say the final score will be calculated something like this: alpha into keyword search score plus beta into vector score. Okay, so this ensures exact match and meaning match here. So like query is best shoe for running. This is your query. Okay, so now here result from keyword search. So for document A, okay, for keyword search, if you talk about here Elasticsearch, document A, the score is 0.9, and document B, the score is 0.3. okay, and same for vector search, document A score is 0.8 and for B it is 0.95. so here in this formula, if you keep the value, okay, place the value where alpha and beta is 0.5, 0.5, so in that case it would be something like this. Okay, and when you solve it, it would be something like this. So it means that document A ranks higher and B still appears. So that is how they rank. Now why this is powerful? Because see, here you are using keyword search. So keyword search handles exact queries, okay, and then vector search handles intent and synonyms. So if you use combination, so best of both words. Now AI enhancement, okay, so if you talk about here enhancement, query understanding is the first one, okay, so like spell correction and intent detection. So for example, if someone has written something like this SHOSE, so he will understand that he is talking about shoes, okay. Second is query expansion. So like if he's searching for laptop, so he will understand that, okay, he can expand it for notebook and MacBook also. Now personalization, so based on user history and click behavior also he will return the result, okay. Re-ranking using LLM, so top result re-ranked using BERT and GPT based models, okay, we just talked about in dimensions. Now conversation search, so if user is writing something like he's doing conversation with him, like with the system, show me cheap running shoes, okay, so he should understand, and then after that he is writing on the Nike, so system should maintain the context that he is talking about what earlier what he has talked. So now end-to-end example, if you see, so let's say you have e-commerce search, okay, budget running shoes under 2000. So here traditional flow keyword match, okay, so filter price less than 2000, it will find the filter also. So AI flow will be something like this, he will understand that budget matlab low price and running shoes means sports category. So final result will be highly relevant plus contextual. Okay, now let's talk about here scaling consideration. So scaling, if you wanted to scale your application, you will use multiple replicas and load balancing, okay. Now write scaling, if you wanted to write same like fast, okay, so write scaling batch indexing, instead of one by one it will store data in index in that Elasticsearch index. So just in a batch you will add that, okay. And then Kafka pipeline, so just add in a Kafka pipeline and automatically asynchronously it will process that data. So batch indexing, inserting multiple documents into the search system in one go instead of one by one. Performance optimization, if you talk about here, so we will be using caching, Redis we will use that, then pre-computation suggestions, okay, and then query result caching. So whatever suggestions you are finding, you just cache it also, so next time when user will come, will get it from cache, okay. And then query result also cache it, so next time that also we will be using. Now caching strategy, if you use here, so query cache, result cache and autocomplete cache, okay. So now here query cache, cache frequent queries, example iPhone, so cache the result of it, okay. Now result cache Redis, so store final result in Redis, faster response for repeated queries. Autocomplete cache, so pre-compute suggestions like SHO to shoes or Shards, okay. Now for example, first search hits Elasticsearch, okay, and then next same search served from the Redis. This is the normal concept. Now if you talk about here trade-offs, so here latency versus accuracy, if you talk, see trade-off means if you're choosing one, then you have to sacrifice the other. See, if you go with latency, if the latency should be smaller, means the system is faster, then in that case you have to compromise with the accuracy, okay. So because ANN vector search, okay, it is faster but slightly approximate. Now freshness versus performance, so here if it is faster refresh, we know that whenever you are adding something in the Elasticsearch, okay, it will go to in memory, then we will create a segment, after that we will refresh it, and then it will be able to searchable. So if it is faster refresh, so in that case it will be more real time, but it will be costly, right? Then cost versus quality, so vector search, it is expensive but it is smarter, okay. So here we were talking about Elasticsearch, and then here we are talking about vector search. This one is also comes into vector search, by the way. Now example, if we talk about here example, so using ANN 99% accuracy but 10 cross faster, okay, acceptable in real systems. So like for example, if it is your traditional system where so that will be your faster and simpler, but poor semantics, okay, he will not able to understand the intent or the context. Then AI based, so it is smart and contextual, but it is expensive and complex. Hybrid, so this is best of both and more infra cost. Now real world system, if you see, so Amazon is using hybrid search, Google is using semantic plus ranking, Okay, Netflix is using personalized search, and YouTube is using AI plus engagement based ranking. Now when to use what? Okay, so let's say if you are using for logging and monitoring, so just go with the traditional one. If you are using for e-commerce, use the hybrid. If you are using for chat or QA, use the AI powered. Okay, feature trends. So future trends. So future, what you can add, retrieval augmented generation RAG you can add here. Multimodal search you can add, like search on basis of image and text. Okay, then voice based search, so user is saying and then he will search it like we do for the chat GPT. Real time personalization also. Okay, whatever result it will give me, it should be personalized to me. Okay, monitoring and observability, so metrics we will track here latency, then query per second, error rate. Okay, and tools we will be using here for like logs, metrics, dashboard and alert. Okay, now here example, latency suddenly increases, so alert will trigger, and then if engineers investigate slow queries. Okay, now real world scale, so here we will having 100 million plus documents and 10,000 queries per second, and then after that indexing delay 1 second we can have. Example, so during sale traffic spikes, system scales horizontally using shards. So summary, if we talk about, so a modern search system is distributed. Okay, it is scalable and AI enhanced. So best system will be combination of Elasticsearch, vector search and AI models. So that's it. Thank you.